Hey everybody, welcome to the Daily Space Weather. Lots of stuff to talk about. The sun, another sunspot to get numbered. It's huge, rising over the southeast limb. Yesterday, you may have realized that it produced an M-class solar flare and a coronal mass ejection, which has already struck the magnetosphere. Talking about polar anomalies, a proton event, and an increased earthquake risk. First thing we're going to do is look at the sun in 131 angstroms. You can see that large sunspot rising in the southeast. It's not quite as large as sunspot 2786, which is the active region now moving into the Earth-facing zone, right into the center longitude there. And we've included a full day of activity here. You can see that coronal mass ejection and solar flare kicking off there yesterday. So here is the view from stereo A, which is at Lagrangian point 5. And indeed, part of that has already struck the magnetosphere. We'll show you later in the video. The radio flux is up to 116 solar flux units, which is quite significant. We'll show you how significant momentarily. First, let me make sure everything is kosher. And just bear with me one moment. We are streaming the video live. And let's get back to the data. Something we're always very interested in. Not fraud and nonsense. So here is the what in the heck? So here's the 10.7 centimeter radio flux shown on a 1-year graph. And Epic Pen is failing me once again. Let me close that down and ignore it for the rest of the day. There you can see the 1-year chart of the radio flux. Again, at 116. So more than halfway up to where it was at the previous solar maximum. And you can see it would be all the way up here if the graph was fully filled in here. Also, the sunspot number is approaching 100. So the sun has ramped all the way back up from nothing up to, it's currently at about 84, and we'll have another, it'll be at least 95 today when that sunspot that's rising gets named. So there you go. Next, we'll look at the LASCO C2 as well as the C3 to show you from the SOHO. Now this is at Lagrangian point 1 in between the Earth and the Sun. Unlike stereo A, which is several weeks behind the Earth, orbitally speaking. And you can see some coronal mass ejection out of the east and the west. And again, some has already struck, increasing the likelihood of large earthquakes. It's the first time we've actually reported on a proton event. Again, we'll show you later in the video. This is a zoomed out version of the LASCO C3. Next, we're going to show you some helioviewer movies. And here's the magnetogram. And you can see sunspot 2786 there, just moving past the Earth-facing longitude. And we can't quite see too much on that rising sunspot yet. Here's 304 angstroms. And next we'll do some 171 angstroms. There you go. So coming off of solar minimum in spectacular fashion, we're going to look at the southern hemisphere. And lots of stuff going on. And this is sort of the reason why we created the channel at solar minimum. So welcome to the Neo Renaissance, folks. Cheers. Thanks for tuning in. And here's a close-up of that new sunspot. And there is a lot of plasma still out there suspended by a lot of magnetism in the southern hemisphere. Fantastic view of that. And next, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com/smAsho. You will get alerts before anybody else does. And we have to have some sort of a financial incentive to have the channel in the first place. Again, patrons are the true source of funding for the content. Patreon.com/smAsho. And for you patrons out there, if you haven't checked your Patreon feed, please do so. You've gotten an early warning before anybody else. Now, today's Smash Light segment will be completely postponed, if not canceled entirely, probably canceled entirely. I would take a moment to invite you to smashomash.com. Check out our social media links, as well as other links to the smashomash.com/forum, as well as our stores. And don't forget, as the scrolling marquee at the bottom of the screen will inform you, that you'll receive a 10% discount on all orders through Christmas at the Smash store and the smAsho store by entering the promo code smAsho on checkout. So make sure you do that. Also, if you enjoy the content, press like and subscribe on YouTube. Thanks everybody who tuned into our M-Class Solar Flare Coronal Mass Ejection video yesterday. It's been a big hit. YouTube.com/smAshomash. Cheers, everybody. Subscribe to our playlists. Press the notification bell. You will receive notifications when we create videos. We've also got live streams and things like that, and lots of other content to be coming out. And again, we're all over social media. Now, today we are streaming this video live to Twitch, twitch.tv/smAshomash. We don't always stream live to Twitch, but it is our favorite live streaming platform. It is simply fantastic. The YouTube platform is okay too. Twitch is just a little bit burlier in my opinion. So here's a quick view here. Twitch.tv/smAshomash. Subscribe over there. Thanks to our followers over there. No cosmology segment today, as there's too much important stuff to cover. Again, please share this video with your friends, foes, science noobs, and science pros. I guess I gotta repeat that daily. And let's get back to some data. Real-time solar wind. And the proton event happened around 8 o'clock universal time. So you can see a shift in the BTBZ here just before that occurs. And that is not uncommon with a lot of protons in between the solar magnetic source and the magnetometers. The GO-16 is located at the F2 ionosphere layer. More about the layers of the ionosphere in a moment. So we saw the phi angle and the BTBZ shift just before that happened. And you can see a bit of an uptick there in the solar wind speed. Not sure how this is going to play out, although I wouldn't expect it to be too much more extreme. We reached a peak there of about 14 protons per cubic centimeter, now currently back down to more of a background level at about 4 protons per cubic centimeter. Solar wind speed still elevated here at 504 kilometers per second. KP index up to 3 as a result of that proton strike. Here's what's going on as far as pressure in the magnetosphere, and you're going to see that proton strike happen right there, where the pressure suddenly drops. I'm going to let this play through a second time. Again, that occurred around 8 o'clock universal time. About 8:15 universal time is when that struck exactly. And we see some increased pressure here continuing as that enhanced solar wind speed I'll let it play through one more time here as it's refreshed. And next, here's that proton flux. And that started to ramp up at about 750, reached its peak around 840. And it's still elevated there in terms of the GOES-16, greater than or equal to 10 mega electron volts proton flux. So here's the one-day chart of that. And it's an ongoing thing. You can see that red line there. That's the GOES-16, greater than or equal to 10 mega electron volt proton flux. There you can see that M-class flare that we covered in great detail yesterday. We even did a live stream about it if you want to go check that out again. That is a YouTube exclusive, youtube.com/smAsho. Here's what's going on above my head. I like to use in-the-sky.org. We've got some interesting polar anomalies also in the ionosphere, which we'll show you momentarily. The moon's just setting where I'm located, and Venus has just risen. By the way, for all of you comet studiers, there's been an interesting article here posted on phys.org's Astronomy and Space section about carbon monoxide gas and comets and so on. Perhaps have a read on that. Don't worry, it's just an artist's impression. But this may be interesting to people like Be Stoic. Shout out to Be Stoic. Here's what's going on in the solar system. And I believe today or tomorrow is the full moon. Let us know in the comments if you know better than I do, as I've got too many things to attract my attention today to worry about it. Here's where things will be in a week. On December 7th, GOES magnetometers are retaining their rather sawtoothed appearance here. That's the 3-day chart of the GOES magnetometer. And for forecasting, we're going to look at the top view ecliptic plane field plot, part of the National Sunspot Observatory. As forecasted, the Earth has snapped into the North Pole current sheet. I would expect the Earth to remain there. You can see the potential field surface source line of the Earth in orange. Also, you can see stereo A located out here. That's Lagrangian 0.5. And stereo B out here, Lagrangian 0.4. Here's a line of sight coronal hole field plot. And you can see coronal hole features there shown up due to all those ground-based magnetometers showing up around the equator there. So lots of stuff going on, lots of stuff. And here's a line of sight field plot which also shows you the more detailed solar magnetometer data, as well as the sun's Z fields in green and red. Here's the coronal magnetic field plot. And you can see lots of closed potential field surface source lines there shown in pink. Open potential field surface source lines shown in black and in purple. So lots of sunspots, significant coronal hole activity, and some strange noises here at the Smash Bunker. Let me take a moment to check on the live stream. And thanks, Sir Giddy, for leaving a comment. Thanks for your kind words. Sir Giddy says, sure wish you did a 24/7 Quake watch with your amazing content. Not much to choose from on here. Well, again, we greatly appreciate that. Cheers. Thanks for the kind words. Sadly, we can't do a 24/7 Quake watch because of financial restrictions. So tell your friends, foes, science noobs, and science pros about the channel so that we can create more content and go full time with this. It's gonna happen. It's just a matter of time. Let's talk about electron flux. We don't see many charging hazards here, although there are some north of the equator there, around places like Mexico, northern South America, and the South Pacific and Caribbean. Here's the 1-year chart of the electron flux. And we're expecting a big downtick here in the electron flux, especially with a proton event happening. And there you have the 3-day chart. And you can see this precipitous drop-off as that proton event occurred. Here's a total electron content forecast. This is a visualization of the entire air column. And we see some anomalies around the poles there in terms of electron flux, as well as surprisingly high density regions around the equator. A thing we typically see when we see a big drop-off in the electron flux, we see more anomalous areas, little blobs of high density. So here's just one slice of the total air column. It's the ionosphere. And this is going to be all over the place, most likely. That would be my forecast. I haven't looked at it yet. I'm actually, again, we're streaming live, and a lot of times I am actually attempting to report on this data and understand it at the same time you are, especially if you're viewing live. A little bit anomalous there. Some sudden charge ups and charge downs of the ionosphere. Here's the latest image from 10:30 Universal Time. And I'm going to just leave this on the screen here for a moment, right after I once again check the live stream. And we are good to go. Here at the smAsho News Network, we prefer for our users to understand what they're talking about. And what we're looking at here are layers of the atmosphere. So first you've got the troposphere. That is where all your weather occurs. Then you've got the stratosphere, where occasionally you get some cirrus clouds and so on. And then you've got the mesosphere, thermosphere, and exosphere. And when we're talking about the ionosphere layer, it goes all the way from, you see that red D there on the right side, D, E, and F. The GOES-16 attempts to measure all of the things that the GOES-16 measures, such as the magnetometer, electron flux, and proton flux, up at the F layer. The F2 ionosphere layer is where it endeavors to be doing its measurements. Keep in mind, this does change as a result of things like pressure on the magnetosphere. As pressure changes the magnetic environment, and hence the expansion and contraction of the atmosphere. So as electromagnetic radiation strikes the magnetosphere and indeed the atmosphere, the amount of refraction, reflection, adsorption, and absorption indeed changes based on the density of the atmosphere. And we're going to show you the D layer, and we see some extreme polar variations in the D layer. It could be anomalous data, but probably not. It's a real proton strike. So anyway, there's that diagram. I hope that helped you a little bit in understanding the different layers of the ionosphere. Again, it does get compressed when we see things like geomagnetic storms and sudden proton strikes. So those protons from that coronal mass ejection sure got here quickly. So here's a visualization of this. Let's see if that expands it. And you're going to see all of a sudden massive high frequency around the poles. Let me advance that as it's moving very slowly. And check it out. We see massive attenuation there, high frequency absorption around the polar regions. And once again, that's happening right as the proton event occurs. See that? Right around 8 o'clock Universal Time. Now, proton events are a risk factor for earthquakes, folks. So the next 24 to 36 hours, don't be surprised to see a large earthquake someplace on Earth. Where? Who knows? We'll give you some of the predictive variables associated with that, too. First, we're going to show you the fact that Luitolo has been erupting again. And yesterday, it did not stop yet. Here's a quick little clip. And I'll leave that I'll leave that in small size here. I don't want to get a copyright strike on the video. Great view of the eruption there. Some sound from a pretty bad microphone. And that's from a USA Today article. Let's see what else has been erupting. It looks like a volcanic uptick indeed. Not just at Luitolo, but at other spots as well. Kluchevskoye is still erupting, although volcanic ash is not identifiable in satellite imagery. Please don't pole vault the caldera. Mount Abico is producing a 10,000-foot ash plume. Cinnabung. Eruption reported by Ground Observer. Luitolo, again, it's produced a 50,000-foot ash plume once again yesterday. Currently, 10,000-foot ash plume there. Don't fly your hang glider over Luitolo. Thousands have been evacuated, by the way. Dacono's exploding, flight level 070, 7,000 feet there. Popocatépetl down in Mexico is exploding, 19,000-foot ash plume. Fuego exploding, 15,000-foot ash plume. Nevado del Ruiz back on the list, 20,000-foot ash plume there. Sangay exploding, 21,000-foot ash plume there as it has upticked. Revenador exploding, 16,000-foot ash plume. And intermittent puffs of volcanic ash at Sabancaya are an indication not to attempt to do a back handspring over the caldera. No major earthquakes kicking off yet. Again, be on alert. If you're in an earthquake-prone zone, know which building facades may collapse if you evacuate yours, as the likelihood of earthquakes has now really upticked. Let's go up the list. So a series of earthquakes there around the Aleutian Islands and southern Alaska. I think I may have alerted about that yesterday or 2 days ago. Here's a 4.6 at New Zealand. That one's at depth. Let's check the location of that. Nowhere near Lake Taupo, but there's a location of that deep quake. And going back to the list here, a deep quake at the Mariana Islands, a deep quake at the Kermadec Islands. I think that might be the largest or perhaps the second largest of the past 24, followed in short order only 2 minutes later by a deep quake in southern Alaska. Largest of the past 24, I believe, is a 5.7 at Tonga. Some aftershocks there as well. 5.4 out in the Aleutian chain. 4.4 magnitude deep quake at Chile. That happened at 6:05. Deep quake strikes Fiji at a 4.5 magnitude at 560 kilometers depth. And no earthquakes kicking off at the moment of the proton strike at around 8 o'clock Universal Time. Here's where pressure cells are located, and we see some anomalous-looking pressure zones here. I'm going to advance this in the GFS forecast. There's where we expect things to be tomorrow at noontime. I'm just going to rock that back and forth a couple of times. That is an anomalous-looking low-pressure system. If I had to guess, I would say the most likely place for a major quake is southern Alaska, unfortunately. And that could be a tsunami risk for the west coast of the U.S. as well. Shout out to all of our viewers who would like to see the west coast washed into the ocean. That's not very nice. Anticyclone over the North Atlantic as well. High pressure ridge. And let's see what else we've got. How about nullschool.net's jet streams? We like to cover it on the daily basis. It's probably the most significant snapshot of weather you could possibly get. It's the 250 hectopascal winds shown right there. The jet streams of the eastern world. And here are the jet streams of the western world. Look at the extreme meridional jet stream flow there in the northern hemisphere. Look at those extreme bends there, 180-degree bends over the North Atlantic, around where that anticyclone's located. And by the way, High pressure zones are the real input to the atmosphere. Low pressure zones are the result. Imagine pressing down on a bucket of water. When you press down on the bucket of water, you create a high pressure zone beneath your hand. And what happens to the area around that high pressure zone? Low pressure zones. Enough of that. LightningMaps.org is where I like to go for my real-time lightning data. I like to convince my friends that I'm Odin and my foes that I'm Thor by correctly forecasting thunder. Hey, Wilmington, there's thunder rolling in. Also, Jacksonville, North Carolina. And Charlotte. Also some lightning there over Central America, the Eastern Mediterranean, and the Central Pacific. Here's a GOES lightning mapper. It's going back a few hours there. And here's a U.S. Doppler radar map. Massive system here over the entire eastern portion of the U.S. practically. And it looks like the strongest line of storms is headed from about South Carolina all the way down into the Gulf of Mexico there, west of Florida. And here's what's going on in the cloud layer. And here's what's going on in water vapor. Cloud layer, water vapor, cloud layer, water vapor. And the reason we show the water vapor map is because it gives folks the best possible details about what will happen next. Often the Doppler radar is very deceptive. So Doppler radar are ground-based radar systems that are measuring movement in the air column. These are satellite systems. This one is measuring shortwave radiation emitted from clouds to guess where the clouds will be located, since you can't see them at nighttime. And this is water vapor. Water vapor can't hide from this satellite. This shows you water vapor not even condensed onto clouds. This tries to guess where clouds are. Hopefully that gives you some insight if you are a meteorological noob. Clouds, water vapor. And thanks for your input, Brett. Now we've got bonus features, and we're going to show you the 335 angstroms 48-hour SDO video, the latest to show you that rising sunspot and how large and in charge it is, as well as the colorized magnetogram. I'm going to vanish, reduce the probability that I'll vanish entirely by becoming a patron, visiting other links, supporting the channel, pressing like and subscribe, and sharing on your social media. Here's that colorized magnetogram. It's the latest image. Here's a close-up of Sunspot 2785, which is this one. Sunspot 2786, which is this one. There is still a significant possibility of coronal mass ejections. There's that rising sunspot. Here are close-ups of the umbrae, and those are still large sunspots, folks. And now that this Sunspot 2786 has moved out of the direct Earth-facing longitude, the likelihood of solar flares actually goes up, as well as for this one. You're going to see about 100 sunspots in the sunspot number today. There's that new sunspot. I believe that's 2789. Frankly, I've lost track. And here's a 335 angstroms SDO 48-hour video. 335 angstroms was a great wavelength to view yesterday's solar flare. And again, check out youtube.com/smAsho. We put out a detailed video with all kinds of close-ups of that scenario yesterday, from stereo A, from the SOHO coronagraphs, as well as multiple wavelengths. We're actually going to close things out today by going back to our HelioViewer movie and thanking our viewers for tuning in. Remember to stare at the sun, attempt to understand the physics. We immerse ourselves in the data. Due to the fact that it is a neo-renaissance, and here is that view in 171 angstroms. We are out. May that solar wind be at your back, and that tsunami not licking at your doorstep. Let's hope one doesn't happen.